Welcome to the June 12th, 2017 Kubernetes SIG Apps. And we have the agenda today, and I know it's been shared once, but we've had a bunch more people join, and so I'll share it again in chat so you can follow along. I'll be leading today. My name is Matt Farina. And if somebody would like to be a note taker or help jump in and take notes on this, it would be appreciated. We can have one person, more than one person. Feel free. The more notes and details we have, the better. And with that, we have one announcement, and that announcement is that over the next couple of months, we're going to kind of put a focus on charts. In the past, we've had focuses on different things, CI/CD, tools, things like that. And charts are now something we'd like to put maybe a little bit more of a focus on. Tools around charts, chart best practices, things of that nature. The idea is we would like to help get charts into a better position and more well-rounded, fill in any issues, and help them get a wider adoption, anything around that. So if you have something you'd like to demo in the next couple of months that will help with charts and any of that stuff, please reach out to us. We'd love to know what those details are or demos are so we can get them on the schedule. Occasionally in the past we've had focuses on things, and this is just kind of going to be our next focus for a little bit. There will obviously be other things happening in the meantime as well. And so that's the one announcement. And then so the flow for today's meeting is we're going to look at updates to Kubernetes. Then we've got a couple of demos, and then we're going to do some stand-ups for some of the projects that are happening around SIG Apps in the community. And then we'll have some open discussion. And so the first thing we have is updates from Kubernetes, and then Kubernetes compared to other projects. And so the first thing that we wanted to kick it off is what's the status of the Kubernetes 1.7 release? And this looks like something that somebody dropped in. Did somebody add that in that they want to talk to? Can you all hear me?
I can hear you.
Yes, I can hear you.
Yes. So as far as I can tell from the Kubernetes 1.7 release, everything's on track. I'm not sure what specifically somebody wanted here. Was there something specific question?
So I will ask, has everybody updated their features that are targeted for 1.7 with the current status, so SIG PM can represent it?
Yeah, hey, this is Dan. I guess to echo Clayton's comment, please update those. And also, there were a few features that got extensions last week. So, but they should, as far as I know, I don't think there's any more that had extensions granted. So I think everything should be, if it isn't in now, I don't know if it'll be a 1.7. So please update those. Thanks.
All right, great. Then let's move on to the other parts of Kubernetes that have been worked on. Does somebody have an update for stateful set?
Yeah, the update feature, which is primarily the one for 1.7 that we were interested in, is merged. Controller history is merged. Daemon set had some updates to leverage controller history, so daemon set history is also merged. We have some additional PRs for E2E and a little bit of API cleanup. But everything's looking on track for a 1.7 release.
Fantastic, thank you. Do we have anybody on for cron job to give a quick update on that?
What features in specific were planned for 1.7 for cron job?
That is a great question.
I think we were trying to get cron jobs from alpha to beta, but I'll reach out to Message to see what he has on that.
So the last I saw on cron job, it didn't get the love that we wanted to give it for this release cycle, and I don't think it was going to make 1.7 for the beta.
Yeah, it's not going to make.
Yeah, that's right. That's right. Go ahead.
Yeah.
Oh, that was all I had. I can see if I can find the feature, but I remember looking for the repo and seeing that it didn't get the love that we wanted to give it. So,
all right, thank you. Was there anything else with daemon set? Because I saw that daemon set history was merged. Is there?
Can I interject on cron job? I'm not sure if this is what you meant by history, but there was a missing feature where you can configure how many jobs to leave behind even when they're successful. Is that the same thing as history?
No, daemon set and stateful set got controller history as a feature for the purposes of update, which isn't really applicable to the batch APIs.
Okay.
There's
No,
that.
actually, it's similar to cron jobs because you can have a cron job that has history of jobs. And I think there are some features in 1.7 where you can specify limits for successful or failed jobs.
Yeah.
Right. And I think that did get in.
Yeah, that's
right?
in.
Right. But we were also going to take it to beta, and I don't think that got in.
No, so I've talked with Machi and she's not going to make it for promoting to beta for cron jobs.
Right. That's all I'm saying.
Okay.
Thank you for the clarifications. Aside from daemon set history being merged, is there any other status update?
Also, the kube control part is also merged for daemon set history and daemon set rollback. And that's all for daemon set.
Thank you. Then there are deployments and replica sets. Do we have anybody who can give a status on where those have been headed?
Updates for 1.7 apart from merging the hash collision avoidance mechanism.
The collision avoidance mechanism was merged?
Yeah.
Great. All right, do we have any other Kubernetes features that anybody wanted to share status or details on? All right, I'm going to take silence as we don't have one. If you do, let me know, and it would be great. Then, so we've got 2 demos today, hopefully. Alex, are you on?
I am on, yeah.
All right, then Casein, can you, the floor is yours. You ready to demo?
Yeah. How do I get?
Can you
can
should
I
just be able
set
to
this-
start screen sharing, yeah.
Okay, great. Okay, can you guys see my screen?
I can.
Okay, so I gave this a somewhat cheeky title. This is mostly tongue-in-cheek, I guess. I think like what I want to talk about today is just the Kubernetes story of like how you write down applications. So like, you know, what container is running, how many replicas, stuff like that. And I think a good motivating question to ask is like, how many APIs do you interact with day to day where the blessed workflow is to like handwrite some JSON and curl that to a server? So I can think of like CloudFormation and Kubernetes, and like that's it. But I think like if you sort of look closely at this, I think this is like not a bad solution to like start with. I think when you look closer, the indication that it's a pain point for the community is like everybody who has any sort of scale deployment on Kubernetes ends up writing their own bespoke toolchain for managing and authoring JSON files and trying to reuse parts of them. And I think like there are projects that have actually made quite a bit of sense out of this, given the tools that they had. Like obviously Helm is like a great example of this, where they use Go templates to sort of get some degree of sharing between Helm charts. But I think it's sort of worth stepping back and just asking a question like, what is this, like, can we do better, and what would such a solution look like? So when we think about this, we ended up settling on like a couple of different goals that were important to us after talking to a lot of people who had experience doing this in-house. So our first goal for the project for Casein was to build better primitives for like expressing the actual Kubernetes API itself. So if you contrast this approach to something like Compose to Cube, which is really taking a different API and mapping it to the Kubernetes API, when we talk to a lot of people who scaled up their applications, we found that an important goal for people is just having good primitives for just dealing with the Kubernetes API. So we're not writing a new API. The second goal that's really important to us is that it has to be compatible with existing code. In particular, it has to be compatible with like the JSON files that people have written. So we think that users should be able to template what they want and not what they don't. And in particular, we think they shouldn't have to like port to like Haskell or like Python or something, right? Like you should have a choice and a gradual path for templating existing code, and it should be amenable to the scaling demands that people have empirically. And the last goal that is important to us is composability. So different parts of the application should be able to be written independently by independent teams, or at least as independently as possible. So for example, the logging infrastructure team should be able to write their part of a deployment object, and the apps team should be able to write their part of a deployment object. And it shouldn't be a single person's job to sort of figure out everything that those apps do and then write it down into a single deployment. Both of them should be able to manage independently the configurations for their different components, and you should have good primitives for combining those. So, hey, Quentin, can you unmute, please?
Yeah, sure. Sorry, I had to reconnect.
No worries. So this is an opinionated workflow. I think like if in the platonic ideal of configuration systems, we might end up with a different thing, right? Like if it was mathematically proven that like Haskell is the way to configure Kubernetes clusters, like that, I think like that, if you don't account for the fact that like the barrier to entry for like, you know, ground up rewrites of like people's configuration is big enough, is like really a big barrier for adoption. I think like a better solution should be possible, but the constraints that we're responding to with the work in Casein is like really pragmatic. We're trying to address this in a way that's relatively high leverage for the community, but accounting for the fact that people have like significant code bases already. So importantly, we're not taking options off the table, right? Like being entirely compatible with existing JSON means that if we decide we want to take a different, more permanent solution later, then we can do that. This doesn't take away that option. Okay, so what is it? So Casein is a JSON library. I didn't come up with the name. That was Sam Goads at Box. JSON, if you don't know, is like a JSON templating language. So it's a strict superset of JavaScript or JSON that includes things like variables, functions, as well as some nice object-oriented features. JSON was an important choice for us because it helps us accomplish goal 2, which is to be entirely compatible with existing JSON configurations. We could have gone with TypeScript, or something like that, but the feedback we got is like people were less comfortable with a full-blown language, and so we picked a language that strikes a balance between being powerful and expressive while still being minimal enough that, you know, a single engineer basically could write the whole runtime themselves. There's also tooling. I don't have time to show you it, but we invest heavily in that as well. So before we go on to the demo, I think that it's important to talk a little bit about the traction we've made in the community and who is involved. So in some way or another, I think of Box, Bitnami, Deis, and CoreOS as having made significant contributions to the project. For the Casein library, Box was the pilot customer. They have about 18,000 lines of configuration code. And for me, a lot of the design decisions that you will see in the demo is sort of based on their use case. It's a little bit slanted towards the maintainability problem rather than the starting new problem. That will change eventually, but I think it's really encouraging that one of, if not the most large configuration code base is willing to expressly work with us to work out the kinks of the core abstractions and to transition their code base to Casein, which is great. I don't have time to talk about what Bitnami is doing. They have a project called kubeconfig in the Casein repository that I'll link to at the end of this talk, which helps sort of nail down a bunch of like the workflow problems, like making deployments like, completely reproducible and hermetic, for example, which is really cool. Okay, so before I show you this code, I do have to say, like, this is like super early. Technically, we call it beta. I would say it's like really alpha. But I think there's enough here that like the concept is, I hope, clear at least. So with that, let's look at some code. So I have 3 demos here. They're not complicated demos. So there are some imports up here. Since it's noise and I want you to concentrate on like the actual code, I am going to scroll down past them. So this is basically a mirror of like the hello world example that's in the Kubernetes documentation. Here we're creating a container. So there's like a container namespace. We .new into it. We create a container called nginx with this image tag, this Docker image. And then the interesting part about this first example is that we use this plus operator to add container ports, right? So the container port is a named port. It's called HTTP and it exposes 80. If I was to comment that out, like you would see on the right-hand side here that the ports section actually goes away. So there's a really strong correspondence between the Kubernetes API, like container.ports is an actual field in the v1.container API object. So there's a really strong correspondence between the API and the Casein library. We do take some liberties with stuff like new to make things more convenient, but the idea is that it should concisely express the API with modern like language tools like variables and stuff. So now that we have like an nginx container, we can pass that to a deployment and we can give the deployment a name, nginx deployment, give it 3 replicas, the container and some label, and the pod label gets populated here. So that's like a very simple example, not a lot of lines of code. The next example will build on this a little bit. There's imports that I'm skipping again to create a service that points at that deployment. So this is still basically the same thing. We're creating the nginx container. There are some common labels that we'll use in the service selector. And we make the port name a variable so that the container and the service port can both point at it. So the deployment object is still basically the same thing. The interesting new part is that we have like a service.new. It's called hello. It selects on these labels, hello and backend, and it exposes service port 80 and points at container port's container name, which is HTTP. And then we wrap this all in a v1 list, which is you can just kube control a list of stuff to the server and it will deploy all of it at the same time for some definition of the same time. So I think like what's important to take away from these examples is not that you understand everything, but you sort of understand the flavor of the language and how this could make things more extensible and maintainable. The last example I want to show you is going back a little bit to the first example. I want to imagine a situation where one team is writing like the deployment and another team wants to embed some volume mount onto every container in the deployment, right? So this part is still the nginx container. This is still the deployment, but the interesting part is this plus append volumes here. And what that does, if you go to this function, it takes like a path that we want. So whatever user share nginx HTML, it takes that and it will append it to every it will append a volume mount and a volume to every it will append a volume mount to every container inside the deployment. So basically, you can ignore, here we're like creating a volume mount, right? Pointed at this path, and then here we create a volume that points at some persistent volume claim, my claim 1. The interesting part of this is when we're mapping over the containers. So basically the logic here is like for every container C, I want to add a volume mount with nginx volume, with this nginx mount that we created. So it'll return that and overwrite it'll append like, the volume mounts in, actually, let me generate this. So it'll append volume mounts to every container, right? So if you look at this, when I comment this out and save it, you'll notice that this volume mounts here will go away. And it does, right? And all we're left with is the volume. But when I uncomment it, it like obviously comes back. And so what you can do is you can create like arbitrarily complex deployments, and you can create arbitrarily complex predicates and append volume mounts to that. And then sort of the app writer has sort of Turing complete flexibility to alter the existing deployment, which means that one team can write this, like the logging team or whatever can write a volume append mixin, and the apps team can write their deployment or whatever. So this is just like a simple example. This all works. It's in a branch in our repository. It's at Casein.lib. So this is the GitHub address. It's just github.com/Casein.lib. All of these examples, you can cube control directly into the cluster. They're in branch, the branch called SIG Apps. So there are 2 branches, one master and one SIG Apps. And it's the last commit, so it's pretty easy to find. So I don't want to take up, I want to leave time for questions because this always spawns lots of questions. I know people have been typing in stuff, but I can't see it yet. Yeah, okay, so how do we start with questions? I actually have never done this before.
Okay. Well, there's some questions in the chat, and I can start reading some of them off. And then if folks want to pipe up with their voices, they can do that as well. And so the first one, and I'm going backwards on this, is you noted that it's Turing complete, and Clayton said, I thought it wasn't. Can you touch on that portion of it?
Right. So, okay. So that's a good question. It is Turing complete. Because the simple way is because you can do recursion and conditionals inside these functions. So I could do something like if blah blah blah, then blah blah blah, else blah, right? So it's definitely Turing complete. I think if you ask Dave Cunningham, who's the author of this, he will say that he has intentionally limited the number of crazy things you can do with it. So I have found empirically writing real applications on top of JSON somewhat difficult to get like an infinite loop, because most things are implemented with recursion and there's a stack limit. Yeah. Okay. So definitely Turing complete. Absolutely. Yes.
All right. Another question that kind of came up, and there was more than one question on this, so I'm going to kind of summarize it. Okay. Your preview on the right appears to be YAML, and you talked about things like JSON along the way. Can you talk a little bit about the capability to go from JSON or Casein in this case into YAML or JSON? What the conversions look like? What's going on there? And what can you preview if you're trying to preview different things? Just kind of touch on that whole space if you could.
Okay, yeah, so what's going on here is that my Visual Studio Code extension is taking the JSON output of the JSON command line utility and turning it into YAML. So natively, JSON does not emit YAML. I think at some point we will want to do that, and I think at some point we will want to be able to import YAML files, right? So like you could imagine, like when I say that this is like fully compatible with like existing JSON code, I mean like we could take like a JSON or we could take like a deployment JSON file and we could just like start adding stuff onto it and then like compile that out with like the JSON command line utility, right? So for example, you can imagine that instead of having this here, I just had like an actual JSON deployment, a deployment JSON object, right? I could then take this plus append volumes and I could just add that to the end of that, and that would work. So to be clear, what doesn't work is since this is a superset of JSON, not a superset of YAML, in order to consume a deployment object that's written in YAML, like on the right-hand side, you would have to convert that to JSON. The conversion is mostly painless, save a couple of corner cases. It hasn't been implemented in the JSON compiler yet, like the JSON command line utility yet, but it will be eventually because it's important for us for a number of reasons. I don't know. I mean, so to answer your question, to answer the question I heard directly, the right-hand side is the product of piping this file into the command line, the JSON command line, getting JSON and then converting that to YAML. I hope that answers. I just sort of smattered knowledge about this this general area on everybody. I hope that answers your questions. If it doesn't, you can maybe ask another one.
All right, I have one more question.
Yeah.
Jason, I mean, this is a new language to introduce here, and it looks similar to something like JavaScript or some of the other, but it's a new language. And Casein is kind of layered on top of that, if I understand it right. Do you have a tutorial on getting started or anything for somebody who wants to learn this? Because, you know, if I'm just going to approach something to go, there's all these language constructs and things that I may not know for anybody who wants to get involved. And so to play the person who's just not familiar with this stuff, do you have anything you could point somebody to if they wanted to get started to learn all of these new language constructs?
Yeah, so the JSONet language has a website called jsonet.org. We are planning to write tutorials that sort of explain the core constructs, but the project is just not. We just haven't had time, right? Like the project has not matured to the point where we have like real documentation yet. So if you're looking for like, you know, like language level constructs, like how do I declare a function? How do I use these plus mixin operators? You know, how do I do an if, right? I would say you can go to jsonet.org and there's a tutorial there. If you're looking for more of the Ksonnet, you know, the introduction to like the core abstractions of Ksonnet, we will be filling out ksonnet.heptio.com more over the next couple of weeks. Right now, it's kind of not in super great shape. It's in particular behind this specific beta. The next version of the beta will come out soon. So I would say if there's interest, I can like update the you know, like SIG apps when we have like real documentation. I don't know how much interest there is for that sort of thing though.
No, that's good. And one of the things that I'll say is just traditionally, you know, giving simple documentation that somebody who doesn't know can jump in and just get started without having to think, or they can start to learn those constructs, really helps uptake even in an alpha. But I understand this is early alpha, so I don't necessarily expect it yet. I was just asking that question if somebody wanted to dive in and give some feedback around it. So no, thank you.
Yeah. I mean, I will say this. Let me say one thing about documentation. I think personally, documentation is a very serious competitive advantage for any open source project.
Mm-hmm.
So we just haven't had time. We will, but it's definitely important.
Okay.
Right.
Hey, Alex, watching some of the commit activity for the Casein project, I've gleaned, I haven't seen it actually stated somewhere, that it looks like the project is a lot of code that generates these libraries. So I get the impression that you're kind of taking the Kubernetes sources, source declarations as input and trying to produce these libraries in a automated fashion. Is that correct?
That is correct mostly. So what we're doing is we're not doing anything as complicated as like crawling over the Go abstract syntax tree or anything. We're basically taking the open API spec for Kubernetes and we're generating the core of the library. So the architecture of this is basically like we have one file called Kates.libsonnet. This is entirely generated by code, and there are some hooks that let us customize like the constructors like new in certain places and alias different functions and collapse things like spec. On top of it, so this is like the innermost of a set of concentric circles of abstraction, right? So on top of that, we have like k.libsonnet, which contains like a bunch of modifications that we're currently making by hand that make the whole API more friendly. Like the map containers function, for example, is here. Eventually, our goal is to have almost all of this auto-generated, and the reason is because we want it to be a build failure if the API changes in a way that's not compatible, rather than leaving something for people to find out, when they're trying to deploy something.
How do you plan to deal with API extensions and third-party resources in that vein?
So I think I would say that we have not yet really thought through the third-party extensions story. I know that Joe Beda is his opinion seems to be that this will be the good basis of a toolkit for creating JSON libraries for third-party resources. What that workflow actually looks like is not yet clear.
Okay.
I think like one thing we might do is like if you deploy a third-party resource into your cluster, maybe you could point kubeconfig at it and get a JSON library for all of the third-party resources in that cluster. But I mean, I don't want to overpromise or anything and say that we've really figured this out, because we have not gotten that far.
So we're having some great conversation here, but we have some more stuff we have to actually touch on in today's meeting.
Okay, sorry.
So no, this is great conversation, and what I would ask is, if folks have more questions or conversation they want to have, can you take it over to the SIG Apps mailing list?
Yeah.
Because there seems to be some interest here, so let's just continue that in another capacity. Thank you very much for the demo and for being able to answer so many questions.
No, thank you. This was really great.
So we have our second demo today of Draft. Matt, are you on?
Yep, I'm here.
All right.
But I'm okay.
All right, sounds good. So the floor is yours to show us Draft.
All right, sure. So to preface everything before I kind of show off the terminal, I just wanted to give an overview of what Draft is and where it came from. So a lot of you are quite familiar with Helm or know about it. Helm, for one thing, has been great for developing an application, putting it up onto Kubernetes and that kind of stuff. One of the troubles that we had at Deis and kind of working around with Draft or with Helm was the issue of developing a chart with Helm or building an application, pushing it up to source, and then actually deploying a Helm chart and doing that development and figuring out how to get that onto the cloud. So that's kind of prefacing and giving you a surface area of where Draft came from. So Draft essentially is a developer tool used to help develop an application, and kind of before you've actually committed to source control and let your CI or CD system kick in and push your application out, build your application and push it up to the cloud. This is kind of like for the person who's building on a fork of their project and trying to build it up and just testing things out. So with that said, I will share my screen and kind of show off Draft. So is this terminal large enough for everyone to see what's going on? Yay, nay?
It is for me.
Okay. I will take that as a yes then. So Draft essentially is a developer tool that runs on the cluster. And also there's a local client available. So Draft version, I've got a version over here, 040 RC1 is the one that I have installed here. And I also have a server version. So a lot of people, if you're familiar with Tiller and Helm, how that interacts, Draft is the exact same way. So in my Kubernetes cluster, kube system, and I get the pod in there, you can see that there's a couple of Drafty pods running in there. There's 3 of them, and then there's also the Tiller deploy pod. This is running off Helm version 2.4. So we're up to what the latest version is. I know 2.5 is coming out sometime this week. So we're going to bump up draft to 2.5 compatibility as well. But so we got that all running. So draft, how it works is that it takes, you don't have to have any previous knowledge of how Docker works, how Kubernetes works, or anything of that sort. So we have a basic application of a Python app that is, if you look in app.py, all it is just like a little simple Flask app, and it's just a hello world web application running on port 8080, and it's got a requirements file. So typical stuff that you would see for a basic Python app for Flask. So to interface and how to start with this project, you would go a draft create. And what that does is that it scaffolds and it detects. It goes through a bunch of packs to figure out what language pack this project applies to, and then it applies that pack to the project. So it noticed that there was a Python app and it calls itself and it says it's ready to sail. And what that did is that it scaffolded a Docker file with using Python on build as a basic one, exposed port 8080, and ran python app.py. And then it gave you a chart directory, which is your Helm chart for this app. And what it does is it's a basic Python generic web app chart that just basically will expose port 8080 by an ingress or by a resource. But the main point takeaway here is that draft create, all it is just the scaffolding in front. And it just creates the stuff for you to get started with your app onto the cloud. And then after that, there's also a draft.toml. It's not really that important, but it just gives you like a randomly generated name. It tells you what namespace your applications are deployed to. So like configurable things you would do with Helm. So then what you do after it's been scaffolded is that you do a draft up. And draft up, essentially it archives your current directory and it ships it up to the draft server, and the draft server pipes back a bunch of build information. So it's piping back a Docker build on your local application, and it's built it. Then it pushes it to a private registry. So here I have my draft daemon set up to push to key.io, bacon gobbler, halting moth is the application name. And so right now we're just waiting for that image to be pushed up, and it might take a little bit of time here. But once that's finished, essentially what happens is that it will now tell, once it's pushed up, it will tell Tiller to install the chart that was done locally, and it will finish that. So let's see if we can go into another terminal here and see if we'll find it in the cloud or in the Kubernetes cluster. Get pod. So this was an old application. Let's see. Draft good eel. Yeah, so it hasn't been deployed yet. So we're just waiting for the registry to push. At this point, I guess I could take any questions if anyone was interested in anything so far, if I haven't clarified on anything that I could clarify further. Let me just see the chat quickly.
That's the wrong chat.
Oh, no, it's Slack and Zoom. What languages are supported? Right now, there are about 6 different languages. And if you go into Azure Draft, I think it's Python, Java, Node.js, but essentially, yeah, Go, Java, Node, PHP, Python, and Ruby. And anyone can create these packs. I know someone tried to create a TypeScript pack, and then there's another one that someone else has wanted to build, which was the Microsoft language. I can't remember which one it is right now, but people are developing those ones as well. But out the gate, we did 6 packs, and it's having a tough time today. So probably can't get that, but.
So here's another question. How does it figure out what ports need to be exposed?
Right now, honestly, it's not intelligent enough to figure out what parts or ports are needed to be exposed. Right now, it assumes in the chart itself, it assumes that it's going to be exposed on port 8080. But the important takeaway here is that it's only being written out to the local file system. So after it's actually been done by draft create, the important takeaway is that if your app does not, or if in the future we want to do a smarter port detection, so then we can figure out if the Python app actually listens on port 880 or if it listens on port 8000 or whatever. If that doesn't happen to be true, then you can just quickly go into the chart and you can modify it to whatever your needs are. You can add extra ingress resources. You can change your chart. It's just basically there for basic scaffolding to get you up and running and hobbling a little bit, and then you can go and run with that, essentially. So,
all right.
Yeah.
Is it, I have one more question if you got a sec here that I see on this chat here, and that is, with a PHP app, how do you determine how to serve it? Apache, Nginx, whatever?
I think that is determined by the PHP Docker image itself. And I think the Docker image itself, I'm pretty sure bundles Apache. I'm not 100% sure on that. But that is bundled within the Docker image itself. So again, this is to get you scaffolding and bundled up and ready to go. If you don't like Apache, if you don't like Nginx or whatever it is, you can change the Docker file or you can change the chart to whatever you need. So if you want to do a separate chart starter image, or you want to run a separate Docker container inside that pod that has Apache and it's just a sidecar container and you're using that to serve your web traffic, that's totally fine. So now just continuing a little bit with the demo since we've now pushed off. The Docker image was pushed to the registry, and then it's just saying this is deploying to Kubernetes. This is essentially Helm taking over. It recognized that halting moth was an application name or a release name that does not exist, and it installed it. And so it just basically does a Helm install with the chart. And then it shows off the release notes here from the actual chart. After which, it'll watch local files for changes. So if we want to, I don't know if I have my ingress set up correctly right now for this, but if I wanted to change the app.py to say, instead of hello world, let's say to hello draft, it will write that, and then it'll automatically notice that we've changed files in the local file system, and it'll rebuild and push it again, and it'll do that. And what will happen in the server, right now we have a Helm list of halting moth at revision 1. What will happen is it will push that new Docker image out, and then it will bump up that revision up to revision 2. So if you made changes to your Helm chart, it would do a Helm upgrade, and it would change that to revision 2. So it would still be halting moth bacongobbler.com or .draft.bacongobbler.com. But your chart would now be at revision, or your release would be at revision 2. So that's the idea there. I think that's all I can do for sharing, so I can just answer questions from here if there's anything else.
Does anyone have any other questions? If I missed one in the side chat, let me know.
Scott Rigby asked, we must have a Docker image locally? No. So what happens here is that it archives the current directory, and what it does is it archives, so essentially how Docker works is that it archives the current directory, skipping out any files that are in Docker ignore, and it sends that to the Docker daemon. We're essentially doing the exact same thing, but we're sending it to draft-D. So no, a Docker image does not be required locally to do this. It just works on application source code. And this is not meant as a deployment tool for production. What happens is that this is just for code to commit. And then afterwards, what you should have in place is you would use this and package it using like Helm package, and actually release a fully CI/CD chart that's been vetted by your CI and your QA team and all that kind of stuff.
So if I understand it right, there's draft, that's the client that runs on your local system, draft D that runs in your Kubernetes cluster alongside Tiller. And so in this case, it tars up the local directory, sends it to draft D running in your Kubernetes cluster, where that's where it creates the container image and pushes it to the repo and does those things?
That's correct. Yeah.
So you don't even have to have Docker installed locally for this to work?
Yeah, you don't have to have, the only thing required to have installed locally is draft. After that, and also your kube config. because it interacts with the kube cluster in the same way that Helm does, in that it uses the kube config to figure out where draft D is installed in the cluster or if it's not. So those are the only two requirements locally to work on this.
Does draft D have to be mounted on the node's Docker socket to do the Docker build?
Yes, it currently does. However, I've been thinking about this and I want to package it with a Docker in Docker container. So then we can ship a different Docker version than what's available on Kubernetes. Because this is one of the things that are blocking a couple of people, is that they want to take advantage of Docker 17.05 capabilities, which are the image within image building. But because Kubernetes currently supports version 1.12, fair sake for them. But for myself and for anyone else, it's just for the image building properties. It's not for the image running properties. So the build process, they would like to take more advantage of the later versions. So I'm thinking of eventually switching it off from the host mounted Docker socket to a Docker and Docker running inside the pod, and then just communicating between the two like a sidecar. And if anyone's interested in the project and wants to talk about the development or wants to talk about issues or whatever else that they're having, I'll link to it in a second, but it's github.com Azure Draft. So.
All right, thank you. Well, we've got just probably over 9 minutes left, and we've got a number of projects to run through for Standup. So thank you very much for the demo. This was useful, and it should be fun to see how this grows and gets used. Thank you. So to switch back to stand-ups here, I just want to kind of rattle through some of these so we can get status and know where they're at. And there's like 5 of them. So let's make it quick, minute or less if we can. Roll through. So let's start with Helm. Mr. Butcher, are you on?
I am. I can do it quick. This week we are finalizing the 2.5.0 release. Its technical due date is a week from today. We may or may not try and squeeze it out a little bit earlier. That's it.
All right. And thank you. That was fast. Compose with a K. Do we have anyone on for that? No. Okay. We'll skip it. App registry, formerly CNR.
Yep, I can talk about that. So last week we gave a presentation at CoreOS Fest, so I can put a link to that in the notes later. We're working on getting our first Quay Enterprise release with support of that internally at CoreOS. So that'll be in the hands of customers who are running the Quay registry on-prem. And besides that, we're just working on some bug fixes in the open source.
All right, thank you. Is the API mostly stable for it?
So far, the API is pretty stable. We've been making mostly UX changes from the client end.
Sounds great. Thank you.
And I would also, we have now Helm requirement.yaml support with app registry, so we can list all your shard registry.
All right, great. Thank you. Then we'll keep rattling on here. Draft. Matt, do you have anything else you wanted to add to Draft besides your demo today?
Nope, that was it. We're all good.
Fantastic. Open Compose. Do we have anyone on for Open Compose? All right. Then we will move on to Monocular. Do we have anyone on to talk about Monocular?
Yeah, I can talk briefly about it. So I don't have much, but I have started to put together a couple of fixes based on some of the issues that are there, particularly more on the deployment side of things. So certain things that were a bit broken, like requiring you to use an Ingress container so that you can map to the UI and an API on the same domain is now no longer a requirement. So you can configure the API hostname and the UI hostname independently if you want to have them on 2 different hostnames. So that's fixed now, and hopefully a couple more fixes within the next couple of weeks.
All right, great. And let's see, there was a recap of the Helm chart hack night discussion. There's two bullets here, which said Vic on Helm charts and operators, and then Scott on local development with Minikube. Is there anybody who wanted to talk about any of this Hack Night stuff?
Sure. I know we did a check-in the last SIG Apps meeting about the local dev, but I can quickly recap.
Sure.
Just what we got to there. So I have everyone's names that was there. Their Slack usernames, but I need to actually click on them to know what their real names are. Sorry about that, but so Michelle, I remember, Ryan J, Tom Davidson, Tony Bellamy, and myself were in that group. And mainly actually, I'm sorry, I don't have my video going. That's okay. Anyway, hello everyone. Mainly we recapped the last SIG Apps meeting to start. Ryan also gave a point of view of what he was working on, which was pretty similar to the first draft of the PR in the charts repo that I put forward that did a host mount directly, if I'm remembering correctly. I don't know if Ryan's on the call, but correct me if I'm wrong, but I believe it was mounting directly to the actual deployment object. I think that's how he was doing it. I might be a little fuzzy on that, but after talking about it more and talking about what Adnan and I had been working through for the Drupal chart PR, that's now really ready to merge. I believe it might need testing by other people, but it looks fine for me and a number of others, a few others. What we're doing is mounting the Kubernetes host path directly to a persistent volume, and then we can already do this without that PR, but it's a little bit tedious because if you're doing this, the presumption is that you're doing it locally, and Minikube has some interesting, very specific recipe to be able to even bind a persistent volume to a claim. But so I charted that and I put that in a chart template. So if you pass a host path for local development, then it will do that recipe, bind the PV to a PVC, as opposed to just making a PVC and then dynamically making the PV, and kind of do that work for you. That all works out properly. I think if you remember from the last week, or if anyone who was on the call the last time, there were some issues where you had to change the permissions on your host machine for the CSS and JS file, or the local Drupal's local files, and then clear the registry. But that's very application specific, and you have to do that whether or not you're charting. It just means that automating that locally is a little difficult because you have to switch back and forth between your host machine changes and your container registry clearing. Aside from that, I know Tom Davidson gave some. I wish he were here to help clarify his he had some reservations about mounting to the PV, because it seemed he was asking about Windows, and it seemed potentially there was a potential difficulty there, and that he was concerned about the option being operating system specific or even cloud provider specific. And what I had mentioned to him is that you can already do this manually without a PVC on any OS, I believe, although I haven't fully tested that. But I know that the Kubernetes host path object, or the host path option, is OS specific or cloud provider specific already. It has, persistent volumes does have specifics per provider. So I think that mitigated that. I think it's just open to the community at this point to whether anyone has any other issue or even possible workaround, because none were provided. So that's what I can remember. Hope that helps.
Yeah. Thank you.
Sure.
And so with that, we are basically out of time. There's 1 minute left. So thanks everyone for coming. We had a packed meeting. Thanks everyone who gave demos. And we'll see you all back here next week. Have a wonderful week.
Thanks.